Welcome to Summarize Science, where we break down complex research for everyone. Today, we're looking at a paper titled When Prompts Override Vision, which explores why advanced AI models sometimes hallucinate. Even though vision language models are getting better, they still frequently describe objects and images that are totally absent. This paper reveals that often, the AI's internal language rules are so strong they completely ignore what the camera actually sees. For instance, if you ask an AI, "What color is the traffic light?" it might confidently say yellow even if there is no traffic light in the photo. They found that this happens because the model is trying to be helpful or is relying on its internal knowledge that traffic lights are common in cities. These hallucinations are a major hurdle for deploying AI in safety-critical fields like autonomous driving or medicine. To solve this, they created a new diagnostic benchmark called HalluScope to find exactly where the AI goes wrong. HalluScope isolates three specific causes: perception failures, reliance on common patterns, and reliance on leading questions. They discovered that hallucinations aren't just about bad eyesight, they are often caused by the text prompt itself. Using a clever construction pipeline, they generated a diverse set of images to test these specific failure points. They used object co-occurrence statistics to identify adversarial objects, which are things that are likely to be in a scene but aren't actually there. The results showed that when a question presupposes an object exists, most AI models fail the test and agree with the user's false assumption. To combat this, they introduced a framework called HalluVL-DPO to fine-tune existing AI models. This method uses preference optimization, where the AI is trained using a dataset of good and bad answer pairs. The model is guided to prefer grounded, honest responses over the hallucinated ones it used to produce. They curated a massive training dataset with over 100,000 queries to teach the model how to stick to the facts. This dataset includes trick questions and detailed descriptions designed to challenge the model's logic. They even developed a weighting system to emphasize samples where there is a clear contrast between truth and fiction. When tested, their optimized models showed a dramatic decrease in making things up. On one specific test, the ability of a model to reject false assumptions jumped from a tiny 6% to over 80%. This improvement didn't hurt the AI's general capabilities either. It actually stayed smart while becoming much more honest. You can see the qualitative results here where the AI now correctly identifies that there are no buses or TVs in specific photos. This work is a significant step toward making AI models that actually look at the data before they speak. By fixing these prompt-induced errors, they are helping to solve an alignment problem between what a model sees and what it says. To recap, the researchers identified that AI often trusts words more than pictures, which leads to major errors. They built a tool to find these errors and a training method to fix them, leading to much more reliable visual reasoning. This means that in the future, your AI assistant or self-driving car might be much less likely to guess about what it sees. It could lead to a world where AI is a more reliable partner in high-stakes environments like hospitals. The researchers are releasing their code and data to the public to encourage even more reliable AI development. Thanks for watching Summarize Science, and stay curious.